So here in this walkthrough, we're going to cover breaking down a GUID partition table. We're going to start to work through this in a very similar manner to how we looked at the MBR partition table structure. By using X-Ways Forensics, Disk Manager, and a little bit of MMLS from the Sleuth Kit to help us guide us along a little bit here. We worked previously before this video started to create a quick test image set up with GPT and a few partitions to help give us something to work with. So starting off with the X-Ways Forensic toolset, we can see here starting off at sector 0 that every GUID partition table has before it a protective MBR. So that's right, every GPT managed storage medium has a protective MBR in place. And there's a number of reasons why that exists. A lot of it has to do with protecting the data when it interacts with or comes in contact with older systems that might not recognize or support a GUID partition table structure. So there is in place a protective MBR. It has some boot code, and it will also have a single partition table entry. This partition table entry has some unique characteristics because it will have a partition type of EE, which according to our resources stands for EFI partition. Moving over here to our starting LBA sector offset, it's going to be 1. And with this 1, we can reference here that we're here currently at sector 0, and moving to sector 1 is the start of our GUID partition table structure. So let's move along down here. Now what we can see here is that we can start to work through our GPT header, and then we'll start to work through our partition table entries. So let's continue with our position manager to break this down a little bit here. Starting off with our first 8 bytes, we're going to have our signature, which is consistently EFI part in ASCII. So we're going to call this signature and assign it a color. Now, moving to the next 4 bytes is our version. And just remember, in an upcoming video later, we'll actually analyze this information. Right now, we're just marking through it. So we've just covered our version. Next up, for a total length of 4 bytes, is our GPT header length. So let's cover this here. GPT header length. Then after that, we're going to have a GPT header CRC32 checksum for 4 bytes. Just giving it some random colors here. Reserved will be 0 for the next 4 bytes. Then moving here for the next 8 bytes is our GPT header logical block addressing sector offset. Coming up next after that, backup GPT header LBA sector offset. Right there. And now the reserved LBA sector count. Coming up after here, we have our usable LBA sector count for a total length of 8 bytes. It's a lot more information in GPT. Header Try and get these colors a little bit brighter. The disk GUID for a total length of 16 bytes. After the disk GUID, we're going to have the partition table LBA sector offset for a total length of 8 bytes. Now after that, we're going to have our, for a total length of 4 bytes, partition table entry count. Then we're going to have our partition table entry length. Then we're going to have our partition table CRC32 checksum. For 4 bytes. And then finally, we're going to have a 4-byte length reserved, which is typically 0. So this breaks down the GUID GPT header. As we move forward in future videos, we're going to break down an individual entry, and then we're also going to talk about what a lot of these important structures mean.